Hello and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler and today we'll be doing Unit 8, Lesson number 5 on Trigonometric Applications, or even easier, trig applications. So we've really learned everything that we need for what we're going to be doing in today and the next lesson, all right? And basically it's as simple as this. We're going to be using right triangle trigonometry in applied settings in order to either solve for a missing side length of a right triangle or a missing acute angle of a right triangle. It's basically that simple. So let's jump right into it. Make sure you have your calculators ready because we're going to need them for today. All right, here we go. Exercise number 1, nothing like a ladder leaning against a wall. It's not just for Pythagorean theorem problems anymore. Now we have trig. Here we go. A ladder will be unstable if the angle it makes with the ground is greater than 60 degrees. If a 12-foot ladder is used to reach a window 10 feet above the ground, will it be unstable? Justify your answer. All right. So what I'd like you to do, given that you have everything you need in order to do this problem, take a shot at this and then we'll talk through it. All right, let's take a look. So now the idea here is if this angle is greater than 60 degrees, I don't want to put a 60 in there because I don't know what that angle is right now, but if that angle is greater than 60 degrees, then it's going to be unstable. Now I should probably give that angle a name, right? I could call it angle A, I could call it angle X, whatever you're comfortable with. It's that angle I need to find to figure out if my ladder is unstable. I guess I'll just call it angle X. Why not, right? Now the right triangle I'm dealing with is this one, okay? And what I know is I know this side, which is the side opposite of the angle, and I know this side, which is the hypotenuse of that right triangle. So if I think about my SOHCAHTOA, what I see is that the correct trig ratio that relates the angle that I don't know with the side I do and this side that I do is the sine ratio, right? Sine is opposite divided by hypotenuse. So I can literally say the sine of angle X is equal to 10 divided by 12. Now in this case, I need to find the angle. I've got the trig ratio, I need the angle, so I'm going to use the inverse sine function, and in fact, make sure you've written this down. X is equal to the inverse sine of 10/12. And now, of course, I need my calculator. So let me jump out of here, go into my Texas Instruments calculator, and make sure your calculator is in degree mode. Right now, mine is in radian mode, right? Again, if you need to get into the mode button is right there. Go down, pop myself into degree mode. Most of you should probably be in degree mode because we've been doing a number of trig problems at this point. But the default mode on your calculator is radians. So if your calculator should ever reset to default, which would happen if your teachers cleared the memory on your calculator, i.e. you've been playing maybe too much Tetris or something on it, then what'll happen is it'll go back to radian mode. Now remember, what I'm looking for is I'm looking for the inverse sine of 10/12. So I come back in here, I'm not looking for the sine of 10/12, I'm looking for the inverse sine of 10/12. So I'll just do inverse sine, 10/12, enter, and there's my angle. The angle that this ladder is making with the ground is roughly 56 degrees. I'll just kind of keep it at that rounding level, right? Because all I needed to do was figure out whether that angle was greater than 60 degrees. See, if an angle of a ladder gets too high, then what happens is that the ladder gets too vertical and will have a tendency to become unstable and slip. This one, though, really, it just says, if a 12-foot ladder is used to reach a window 10 feet high above the ground, will it be unstable? And the answer is no. The angle it makes is less, not a lot less, but is less than 60 degrees, right? It's that easy. Now in this case, we were solving for a missing angle in this applied trig problem, but we'll also on occasion solve for missing sides. So let's keep going and do some more trig applications. All right. Let's talk about the keys to applying trigonometry. One, know which trig ratio you're using. Okay? Am I using sine? Am I using cosine? Am I using tangent? Know whether you're solving for an angle or whether you're solving for a side. That's very important. All right? And that's it, right? Those are the keys to using trigonometry in any applied setting. Know which ratio you're using and know whether you're solving for a side or an angle. Everything else is algebra. It really is. So let's do some problems. All right, we've got a person in a tree. All right, and this is kind of classic. Right? A person goes out, 5'3", and they take a spotting scope and they can elevate it so that they're looking at the top of a tree. Then they can come and they can actually look at the angle of elevation to the top of the tree. And in this case, standing 25 feet away from the base of the tree, the angle of elevation from the person's eyes up to the top of the tree is 38 degrees. And what this problem asks us to do is to figure out the height of the tree to the nearest inch. I won't go and read through the entire problem because I think I pretty much just laid it out for you. We need to find the height of the tree. Now keep in mind that the height of the tree is this entire height. And that's not part of the right triangle, right? The piece of the right triangle that we can really figure out is this length. That I can figure out. So let's do that. Let me call this x. And for a moment, let's not worry about the height of the tree. Let me draw that picture a little bit separately out here because I don't think that you can see it all that well. Right now, what I have is I have that 38 degrees. I've got that 25 feet. And I've got that x that I'm trying to solve for. Okay? So, which trig ratio should I use? Well, I should use the tangent ratio, right? And the reason I should use the tangent ratio is side x is opposite of the 38, and the 25 feet is the side adjacent to the 38. So what I can now write down is that the tangent of 38 degrees is equal to x divided by 25. Okay, this is going to be very, very easy to solve. Remember, when we solve for missing sides of a right triangle, I can just multiply both sides by 25, and I'll find that x is 25 times the tangent of 38 degrees. Let's go ahead and evaluate that. 25 times the tangent of 38. 25 tangent 38 equals 19.5321. All right. Now, this is a little tricky for many, many students. 19.5321. If I want to figure out the height of my tree, I've got to take this height, 19.5321 feet, and I need to add it to the 5 feet 3 inches. And I want to figure out the height of the tree to the nearest inch. All right, so what might make some sense is to figure out what this is in terms of feet and inches. So right now I have 19 feet and some amount of inches. So this can be tough for students, all right? How do you take something like this and convert it into 19 feet and blank inches? Well, keep in mind that what we've really got is we've got 19 feet plus another 0.5321 feet, right? A little bit more than half of a foot, right? We don't have, really, really important here, we don't have 19 feet and 5 inches or 19 feet and 53 inches. That would be really weird, right? We have 19 feet and another 0.5321 feet, right? So, going back over to my calculator, I really want to know if I have 0.5321 feet, how many inches is that? Well, just like always, if I multiply that by 12, that's how many inches I have. 19 feet and 6.3852 inches. I'm going to say 6.4 inches. 19 feet, 6.4 inches. Now I need to take that and add to it the 5 feet 3 inches. Why? Because I want the height of the tree, and the person spotted that 38 degree angle 5 feet 3 inches above the ground level. So the actual height will be 19 plus 5, that's, if you will, the feet, and then it's plus 6.4 plus 3, and these are the inches. Oh, I don't have a lot of room left. I'm going to bring this up here. 19 plus 5 is obviously 24 feet, and then 6.4 inches plus 3 inches to the nearest inch is 7 inches. So the height of the tree is 24 feet 7 inches to the nearest inch. All right, and probably the hardest part of that isn't the trig, it's taking the 19.5321 feet and converting it into feet and inches. Remember that portion after the decimal point is the fraction of the foot that you have. Take that, multiply it by 12, and you have how many inches you have. Let me just step out of the way for a second so that you can copy any of this down, and then we'll move on to the next problem. Okay, let's do it. I'm going to go back to the full screen view, and let's take a look at the next one. All right, all applied problems, all trig, all the time today. Exercise number 3. An isosceles triangle has legs of length 14 and a base of length 10. What is the measure of its vertex angle to the nearest degree? All right, well, what I'd like you to do is pause the video now, take a shot at this, and see if you can figure out what the answer to this problem is. Draw a good picture, though. All right, let's take a look. We have an isosceles triangle. It's got legs of length 14 and a base of 10. All right, so those are my two equal legs. Call that 14 and 14. And then a base of 10 and a little bit of a miss there. All right, that's okay. Now we want to know the measure of the vertex angle. One of the most important things with right triangle trigonometry is it can only be used for right triangles. This is not a right triangle. On the other hand, if I slice this thing in half, now I have two identical right triangles. Okay, let me draw one of those identical right triangles right here. Now that 14 didn't change at all. But obviously that 10 got sliced in half to make it into 5. Now, I need the measure of this vertex angle. I need this whole angle. But up here, I have only half of it. I'm still going to call it x. But what I have to remember is once I solve for the value of x, which is an angle, I then need to double it to actually find my vertex angle. Still, the procedure besides that is pretty similar. The 5 is opposite the x, and the 14 is the hypotenuse. So it looks like, yet again, I need to use the sine ratio, right? Opposite divided by hypotenuse. So I'm going to say the sine of angle x is equal to the opposite side, 5, divided by the hypotenuse, 14. Now remember, one of the keys to solving any kind of an applied trig problem is know whether you're solving for the angle or a side, and here we're solving for an angle, and every time we solve for an angle, we need to use the inverse trigonometric functions. In fact, that angle I'm looking for is going to be the inverse sine of 5/14. So let's actually take a look at what that is. All right, let me clear this out. Let me do the, whoops, no, that's the sine. I need the inverse sine of 5/14. So x is going to be 20.92, etc. Right? Let me just write that down really quick. So x is 20.92, etc. Big decimal point there. But that's not my answer. Always keep your eye on the target when you're doing a math problem. Make sure not to stop too soon. I want this vertex angle up here, which is a combination of an x and an x. So let me come down here and say that my vertex angle is equal to 2x. And now I can go back over to my calculator. You probably all know this trick. I can just hit times 2. And that will take my previous answer, which was x, multiply it by 2. Not surprisingly, I'm going to get a rounded answer of 42 degrees, 41.849, etc. So 42 degrees. All right. Let me go back into full screen so you can write down anything you need to. All right, let's move on. If these problems all kind of seem very similar to each other, that's because they are, all right? Get good at them, all right? You might see some kind of big one on a standardized exam. You score perfect points on them because you're just setting up these trig ratios and doing some fairly simple algebra in order to solve them. All right, let's take a look at a ship problem. I like ship problems. A lighthouse in Cape Hatteras, North Carolina is 200 feet above the sea level. If it spots a boat that is at an angle of depression of 28 degrees, as shown, what is the horizontal distance to the base of the tower, round to the nearest foot? So this is kind of cool because it really is something that used to be done. Again, nowadays with GPS and the fact that GPS is everywhere, maybe not as much. But it used to be that people in the top of a lighthouse, which we know is 200 feet above sea level, would spot a boat way down in the water. And they'd take their scope out and they would start to look down. And they'd say, okay, I now see that boat in my scope. What's that angle that I went down? Oh, that angle is 28 degrees. And now the person up in the lighthouse, who's good at trigonometry, is able to figure out how far the boat would be from crashing into the shore, to be quite honest. Okay, so what I'm trying to figure out here is this distance. What is the horizontal distance to the base of the tower? Again, I'll use my favorite variable ever, which is x. All right. But now this is kind of weird because I've got this side I want, which is x. I've got a side I know, which is 200. I've got this angle, 28 degrees, but that's not part of this particular right triangle that I'm dealing with. But here's the key, right? This is parallel with this, which means this 28 degrees is also this 28 degrees. And that kind of makes sense. The angle that I'd have to rotate down to see the ship is the same angle that the ship would have to rotate up to see me, all right? And now we have everything we need, right? We've got the angle in a right triangle. We've got a side length that we know. We have a side length that we want. We just need to solve. Pause the video now and see if you can figure out how far this boat is from crashing into the shore. All right, let's go through it. Well, the 28 compared to the 200 is opposite. The thing we're solving for is adjacent. Opposite and adjacent tells me I have to use the tangent ratio. So I'm going to say the tangent of 28 degrees is equal to that 200 divided by x. This is one of the slightly more difficult ones because the variable we're solving for is in the denominator rather than the numerator. Big deal. I'm going to multiply both sides by x to cancel that x. Now we have x times the tangent of 28 degrees is equal to 200. Divide both sides by the tangent of 28 degrees. Right? And we're going to have x. We just have to take our calculator now and do 200 divided by tan 28. So let's do it. We'll clear this out. 200 divided by the tangent of 28. And it looks like we are 376.14, etc. I bet it's rounded to the nearest integer. Let's see, what is the horizontal distance? Round to the nearest foot. 376, I believe it was. You bet. So 376 feet. All right, that's it. Pretty easy. We've got one last problem that we're going to do in a minute, but write down anything on this that you need to. Okay, let's do it. Now the last problem is a little bit more complicated, and we'll talk about why in a moment. All right, but first let's read through the problem. A blimp hovers above the ground at a height of 1,150 feet. An observer at point A sees the blimp at an angle of elevation of 24 degrees, while an observer at point B sees the blimp at an angle of elevation of 38 degrees. What is the distance to the nearest foot that separates the two observers? So this is kind of cool, right? If we know the height of this blimp, and we know how sort of much that this person has to elevate in order to see the blimp, and likewise over here, we can actually figure out the distance between the two people. But the key is, again, with all right triangle trig, you must use right triangles. The key here is that there's two of them, and unlike the isosceles triangle exercise, they're not identical right triangles. That's a little bit unfortunate, but here are the two right triangles, right? One of them kind of looks like this with 24 degrees, a height of 1,150, okay? And what I want is I want this distance, x, right? That's this, right? This would be a distance of x. And then the other right triangle, right, is this one with that 38 degrees, okay, also 1,150. I should call this distance something other than x. Shouldn't call it x. Again, bad form. I'll call it y. Why should I call it y? Just because I can. All right, so I want that distance. And now what I have to do, no great shock, is I need to solve for x, I need to solve for y, and then I have to add them together, okay? And we'll do that addition all at once, okay? So that we don't have to get a messy value for x and messy value for y, then put them in our calculator. We're going to do it all at once, all right? But what I'd like you to do is set up some trig ratios to solve for x and y, and then we'll take it from there. All right, let's go through it. Well, in both cases, one of the nice things is that the trig ratio is going to be the same, all right? I can't get rid of that. Anyway, and that trig ratio in both cases is going to be the tangent ratio because the side length that we're trying to solve for is the adjacent side, and we know the opposite. So in this case, we're going to say the tangent of 24 degrees is equal to the side opposite, 1,150, divided by the side adjacent, x. Again, a little bit annoying because what we're solving for is in the denominator of this ratio. But we can multiply both sides by x, cancel that out, then divide both sides by the tangent of 24 degrees to get the x all by itself. And we'll find that x is equal to 1,150 divided by the tangent of 24 degrees. Now, no great surprise, we're going to have something very similar over here as well. Maybe I'll start it up here. We have the tangent of 38 degrees is equal to 1,150 divided by y. So y times the tangent of 38 degrees is equal to 1,150. And y is equal to 1,150 divided by the tangent of 38 degrees. Now, we could take our calculators and put this in, get a messy decimal, put this in, get a messy decimal, write them down, then put them both into our calculator. But we can do it all at once. Remember, one of them is 1,150 divided by the tan of 24. One of them is 1,150 divided by tan 38. So, here we go. 1,150, divided by the tangent of 24, right? That's this one. 1,150 divided by tan of 24. Plus 1,150 divided by the tangent of 38. Now it's very important that you've got the parentheses closed on the 24 and the 38. Without them, the calculator gets all sorts of confused and will give you the wrong answer. But there it is. They are 4,054.87, etc. feet apart. So rounded to the nearest foot, they are 4,055 feet apart. 4,055 to the nearest foot. X plus y equals 4,055 feet. All right, that's it. So the only thing that was more tricky about this problem than the other ones was that we had to set up the two trig ratios because there were two distinctly different right triangles here and then we had to add the answers. All right, take a moment with this problem, then we'll wrap up. All right, let's do it. So, we really didn't introduce anything new today. All we did were application problems that involved the trigonometric ratios to either find a missing side length of a right triangle or find a missing angle of a right triangle. And that's it, right? As long as you know your three trig ratios, how to set them up, and then how to solve for missing angles versus missing sides, all of these problems are actually quite similar. And we'll look at some more in the next video as we do one more lesson on trigonometry and trigonometric applications. Until then, I just want to thank you for joining me for another Common Core geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.